We are solving a AIPMT problem in current electricity basing on meter bridge. It says the resistance of 2 arms of the meter bridge are 5 and R. There the balancing lengths are given as L1 minus 100 minus L1. So, what we can write? When a meter bridge is balanced, we know the condition that P by Q equal to L by 100 minus L, where P is the resistance in one gap and Q is the resistance in another gap. That implies I can write 5 by R equal to L1 by 100 minus L1. That is case 1. What is case 2 that he has given is when the resistance of R is shunted with an equal resistance R. So, to this R, shunted means adding small resistance in parallel is called shunt. There is another resistance added. Now, the balancing length is 1.6 times of L1. So, case 2, when R is shunted to R. So, this R and R are in parallel. So, the effective resistance R parallel equal to, I have a formula R1 R2 by R1 plus R2, you know this formula, both are R only. So, that becomes R by 2. So, in the second gap instead of R now there is a new resistance R by 2. So, again what we can say, when the bridge is balanced, I can write a formula 5 by, in the place of R, as there is another resistance shunted, I have to write R by 2. In the place of L, I have to write 1.6 times of L1 by 100 minus 1.6 times of L1. We call this as equation number 1. So, 5 into 2 becomes 10. 10 by R equal to 1.6 L1 by 100 minus 1.6 L1. This is equation number 2. So, let us make 1 by 2 and see what happens, right. Let us see. Equation number 1 by equation number 2 gives, one's left hand side is 5 by R, second left hand side is 10 by R, one's right hand side is L1 by 100 minus L1. Here right hand side is 1.6 L1 by 100 minus 1.6 L1. So, this R and R will cancel. 5 by 10 equal to 1 by 2. This is L1 by 100 minus L1. This denominator of the denominator goes to the numerator by 1.6 times of L1. L1 will cancel. So, what is remaining is 1 by 2 equal to 100 minus 1.6 times of L1 by 100 minus L1. Let us cross multiply this. What happens is 2 into 100 is 200, 2 into 1.6 is 3.2 times of L1 equal to 100 into 1 is 100 minus L1, right. So, what happens now? Yeah, I missed one thing. So, look at this carefully. L1 got cancelled. So, what is remaining is 1 by 2 equal to 100 minus 1.6 L1 by 100 minus L1 into 1.6 is there. I have forgotten writing that 1.6. So, let us recalculate what happens now. What happens now? This implies 2 into 100 is 200 minus 2 into 1.6 is 3.2 times of L1 is 100 into 1.6, 160. 1.6 into L1 is 1.6 times of L1 into 1 means remains the same. So, get this 160 to this side, 200 minus 160. Take this 3.2 to the other side, it becomes plus. So, 100 minus 200 minus 160 is 40, 3.2 minus 1.6 is 1.6 times of L1. That implies L1 equal to 40 by 1.6 or 40 by 16 by 10. By 10 goes to the numerator, right. So 4 4s are 16, 4 10s are 40. 10 into 10 is 100, 100 by 4. That implies first balancing length is 100 by 4, 25 centimeter. But what he is asking is not that 100. What is that resistance R is? So once I got L1, I can substitute in equation number 1 or equation number 2. Being equation number 1 is simple, I will do it in equation number 1, right. So substituting L1 in equation number 1 gives, this is our equation number 1, 5 by R equal to L1 means 25 by 100 minus 25. So 5 by R equal to 25 by 75, that is 3 times. So 5 by R equal to 1 by 3, that implies R equal to 15 ohms. 15 ohms is the answer for the problem. So this is a very simple problem. You only need to know the conceptual clarity to solve this problem, right. Relook at the problem. You can make a comment if there is anything that you don't understand. Thank you for watching.